On the show, that's Jim Castellano, Vice President, Design Engineering for Electric Vehicles. And now my understanding, because I've already talked to you in advance, is you guys don't actually produce electric vehicles, but you guys are producing the technology to help electric vehicles work. And I'm sure I got that wrong. So why don't you explain it better?
Technology we produce, we make the automotive components, we make the motors, the inverters, the battery controllers. So we make many of the components that operate the vehicle. And those are for whether it's a hybrid, a plug-in hybrid, or a full battery electric. They're all enabling technologies that we produce. And, you know, with the customers, we produce for almost every OEM. Some are to their specification or to our specification. And obviously, the goal is to make the most efficient, most affordable components of these devices.
So Jim, how did you get interested in electrification technology and electrifying the car?
Yeah, thanks, Matt. Yeah, you know, I've always been excited about automotive industry. Matter of fact, I left New York to come to school at Western Michigan. They had an automotive engineering degree at the time. And from that, I was lucky enough to be hired into Ford in 1983. And as an engineer, always interested in new technologies. So back in December 99, Ford started a hybrid program. I volunteered to join that team. I was the sixth person on it, so I was very lucky to get on that. And, you know, one of the things that drew me to that was, you know, the positive impact it would make on the environment. Fuel economy was a wonderful thing, but really, you know, I was growing up, I had three little ones at home, Boy Scout leader, Cub Scout leader, and this whole impact for the helping the environment was what really drew me into the electrification technology.
So what are the important differences between hybrid and battery electric technologies, and are there advantages one over the other?
Yeah, thanks, Mike. Good question. Yeah, so, you know, we started out in the hybrid world. The hybrid world is what we used to call a charge sustaining vehicle. You never had to plug it in. So it would run the engine at the most efficient modes when you were using it. And then when the engine was off, you captured energy on regen braking or during braking. And the batteries then really powered the vehicle, and a small amount of electric range, but allowed you to use the electric sort of as an electric turbocharger, where when you needed a boost of power, you had the electric motors. You would start on a high voltage, and this made engine downsizing possible and used less energy. As we move into the battery electrics, obviously they're full electric, and you know, from a vehicle standpoint, the CO is effectively zero. And then in between those, we have plug-in hybrids where you can get moderately good distance now with the lithium batteries and provide zero CO during the city ranges. And then when you go beyond that, you're still able to have a longer range distance with the IC engine.
So the advantage of the hybrid is longer range, but the battery is, you know, obviously not. It has zero emissions, right?
Right. I mean, it allows you to. Right. The hybrid allows you to run the engine, but you can run it in controlled situations, and you can change the architecture of the engine to allow it to be lower in emissions as well. So it allowed you to achieve the PHEV certifications much easier while enabling some electric range. And of course, then once you get to the BEVs, it's all about you know, range and capability.
So what about the issue of, well, you're driving an electric car, but where does the electricity come from? I know the electric utilities here in Michigan are on a mission for, I think it's more than half green energy by 2030 and net zero carbon by 2050. That to me kind of helps the case for battery electric vehicles in that you're not burning coal or oil or natural gas for the electricity, right?
Yeah, you know, the infrastructure plays a big role. Obviously, that's a little bit outside of my area expertise. But when you talk about affordable electric vehicles and environmental impact, you know, when you look at it from well to wheels, where does that energy come from? Clearly, hydro, nuclear, wind, solar play a big role as we move forward for clean and efficient sources of energy. And then recyclability, right? After the automotive battery is done, in many cases, we can use those power devices. So lots coming down that path.
I've read that you hold a couple of different patents for high voltage battery systems. Can you tell us about those patents?
Yeah, sure, Mike. Thanks. Yeah, when we started the Escape Hybrid, and it was back released in 2005 model year, so it's a bit dated. One of the areas we were still at nickel metal hydride batteries at that point, and as we developed those batteries, what we wanted to do is have a hybrid that wasn't taking anything away from the consumer or the customer as they drove the vehicle. And battery cooling is a critical stake. You want to keep those batteries at a pretty nominal temperature and make them most efficient as possible. So the patents, I was lucky enough to work with a team of other engineers. We came up with strategies on how to cool the batteries by utilizing outside air versus cabin cooling, and then how we manage the fans so that the NVH didn't impact the driver by blowing the fans very loud or not. So a couple on the control side and a couple on the mechanical side.
So I'm just curious, those first generation hybrids, the Escape Hybrid, are, to your knowledge, are there any of those still on the road? What was the battery life on those like?
Yeah, so they were a different chemistry. They were nickel metal hydride, so that was a big challenge, right? Developing a key life test for something like that. And as I said, I'm from New York. I was lucky enough to go visit my mom on Mother's Day, so I went through the city, and I was still surprised to see those early hybrid Escape taxi cabs driving around New York. So they've proven to be very reliable. My neighbor actually still has his at 204,000 miles on it. And so we warranted those batteries. The California had a 10-year life, 100,000 mile. The other green states were 8-year, 80,000 miles back then. And so from a reliability standpoint, we really did focus that we had to gain that 10 years. So everything we had was for 10 years of useful life, not just design.
So how does holding a patent on technology make it easier for you to reach career goals, professional goals?
Yeah. As an engineer, I don't think there's anything more rewarding than getting a patent. And I've done a fair amount of that, been in the industry for about 40 years. First 35 and a half were at Ford, and the last 5 now at Hitachi Astemo. And one of the things I do is when I'm mentoring the younger engineers and we have that discussion, is when you have a patent and you see that vehicle going down the road, you just have a different sense of pride. You know that you've shared this. And we have many patents that don't get always to the final stage or on a vehicle, but once they do, it's really wonderful. It also helps you intellectually protect the intellectual property for the company as you work in teams and you develop these. And sometimes that's shared across the industry, and and it's leveraged between companies, but it is really rewarding for the engineer to have a patent.
How do you see the automotive industry in the region changing with all these EVs and hybrids and whatnot coming online versus the internal combustion engines?
Yeah, I know there's been lots of press exactly when, and I'm not a marketing guy, I'm an engineering guy. So I do see the change. For me personally, I do think we need to change the impact to the climate control elements and such. We see that's real, but it's a balance. It's always been a balance in the industry. I think IC engines will wane as fuel prices and such, and the emission requirements become so much more stringent. But I do think we have hurdles to overcome in an industry the automotive industry is tough. It's got to be safe and it's got to be affordable. And as we gain on this new technology, the key is to make it a valuable vehicle. And I think the team and all the other companies are working towards improvement in these areas.
Yeah, I was gonna ask you about the price of electric vehicles, because obviously Tesla started out at a very high price point, and then they have the Chevy Bolt was a very affordable electric vehicle, although it's being replaced by a couple of electric small SUVs going forward here. But do you see affordability getting better, or do you see that stuff costs what it costs and the price of these vehicles is going to stay about the same or go up a little?
Yeah, I think while you talked earlier in the conversation with Keith, the price the price of the vehicle is being driven mainly by the battery. The other
Mhm.
technologies, I think, have come down tremendously, and are, you know, in some ways cheaper than some of the IC or diesel applications with all the after treatment that goes on them. I do see, you know, from my early beginnings where the battery prices continue to go down, but that is going to be key, right? Because as you noted, the earlier cars, you know, maybe the North America companies went a little bit the wrong way. We tried to do everything small and affordable, and, you know, Tesla came in and said, you know, I don't want the early adopters at a different price break point that are going to accept some of those technology challenges. You know, Ford had the BEV Focus, and GM had a range extender Volt, and then came out with the Bolt, and those were focused on really trying to keep the price down. But you know, battery prices were quite expensive, and the range wasn't there. And you look today, as we now go towards bigger vehicles, mid-size type vehicles, we would call them C+ type vehicles, and even pickup trucks, where they're getting ranges of nearly 300 miles or more, depending on, you know, the drive cycle and mode. So I do believe the prices will come down. Volume will have a lot to do with that. The enabling technologies, as we always do, as we learn and build more, we're going to get smarter each time.
All right. Well, Jim's going to be joining the Powering Electric Vehicles panel at Lawrence Tech on Wednesday. And the panel discussion kicks off around 9:30. I know there's a breakfast before. And Matt Roush is a moderator, right, Matt?
Absolutely. Yeah, I'm looking forward to speaking to all of our panelists about what they see over the horizon and what they see in the next 5 or 10 years for electric vehicles.